Hello, everyone. It's Dr. Messina Morris, and it's Friday, and I want to hop on here really quickly and give you all some tips and hints about an AI tool that I've been using primarily for our AI teaching assistants and tutors at Morehouse College, but also with educators around the globe. And so it's really important for me to drop this little tidbit of information for you to understand a little bit more about Holotutor AI, how it works. And so I just need to share this because it's on my mind. And so, you know how it goes on Friday. I got to get it out of my mind into the people. So here we go. I am going to go to, let's just do my entire screen. We're friends here, right? Right. So you can see a lot of me. All right. So I am going here to holotutor AI. I'm actually going to go back here and share. Let me remove this. I'm going to just share stop the screen and share the tab with you. Awesome stuff. Okay. So you see the interface for holotutor.ai. And a lot of people have asked, well, how do you know that your students are actually learning, or how can you tell? The goal is to be able to provide them with information that works well for them in their learning, and giving them the autonomy to ask 24/7 questions and get it in a format that is going to just give them educational information. And so um, you can ask the tutor for help with reviewing material by uploading a document. You can ask for guidance in the subject area, but I am going to ask it to explain atomic number. And I'm just going to say at a basic level. I'm going to choose high school because most high school students also use it. And I want it at a pretty basic level.
The atomic number is the number of protons in the nucleus of an atom. It's a unique identifier for each element on the periodic table. For example, hydrogen has an atomic number of 1, meaning it has 1 proton. The atomic number determines the element's identity and its position in the periodic table.
Some of the things that you don't think that you can actually ask these conversational avatars is things like, why did you choose that as an explanation for me?
I aimed to provide a clear and concise explanation, focusing on the most essential aspect of the atomic number, its role as the unique identifier for elements based on the number of protons. This helps build foundational understanding without overwhelming detail.
I am a student with level 1 autism, and I need you to make that more concrete for me. I like cookies.
Think of atoms like cookies in a cookie jar. Just like each element has a unique number of protons, the atomic number is like counting the chocolate chips to see what type of cookie it is. If a cookie has 1 chip, it's a hydrogen cookie. More chips mean different cookies, just as more protons mean different elements.
So if I had 3 chips, Would I be lithium?
Exactly. If a cookie has 3 chocolate chips, it would be like lithium, which has an atomic number of 3. This means it has 3 protons, just like your cookie has 3 chips. Great connection.
How is the atomic number related to the other numbers on the periodic table? There is a lot of numbers.
On the periodic table, the 2 main numbers are 1. Atomic number, the number of protons in an atom, defining the element, like the chocolate chips. 2. Atomic mass, the average mass of an atom's protons and neutrons. It's usually a larger decimal number. The atomic number is usually found above the element symbol, while the atomic mass is below it. The atomic mass helps you understand the size and weight of the atom compared to others.
Why is the atomic number not a decimal, but the atomic mass is?
The atomic number is always a whole number because it counts the number of protons, which you can't have a fraction of. The atomic mass is a decimal because it's an average of all the isotopes of an element. Isotopes have the same number of protons, but different numbers of neutrons, so the mass varies slightly. The average takes these variations into account.
So I just clicked isotopes because that's a new word. So what are isotopes?
Stable isotopes, due to their non-radioactive nature, play a crucial role in scientific arenas like paleoclimatology, where they help reconstruct past climates, and in ecology, where they track food webs. Additionally, their stable atomic structure allows for precise isotopic labeling in biochemical studies, aiding in the understanding of complex metabolic pathways without the risks associated with radioactivity. Sure thing, an isotope is like a variation of an element, where the number of neutrons is different, but the number of protons stays the same. Imagine the same cookie recipe, but with different amounts of sprinkles. Still the same type of cookie, just a bit different.
So my lithium will have 3 chips, but maybe like 4 sprinkles and 3 chips, but 3 sprinkles.
Exactly. Your lithium cookie always has 3 chocolate chips, but it can have different numbers of sprinkles, neutrons. Those different sprinkle amounts make different isotopes of lithium. Great analogy.
What else do I need to know about elements on the periodic table to help me understand orbitals?
To understand orbitals, start with these basics. 1. Electrons. Orbitals are regions where electrons are likely to be found. Electrons move around the nucleus in these spaces. 2. Energy levels.
Hold on.
Electrons are arranged in layers or shells around the nucleus.
Talk about
These are like the
electrons.
floors of a building, with orbitals on each floor. Types of orbitals. There are different. Electrons are tiny, negatively charged particles that orbit around the nucleus of an atom. They are like the outer layer of the atom, moving in specific regions called orbitals. Their arrangement helps determine how an atom behaves and interacts with other atoms. Here's a diagram of an atom with labels showing the nucleus, protons, neutrons, electrons, and orbitals. This should help you visualize how everything fits together.
Hmm. Let's see. Okay. So it does show you the protons, which are positive, the neutrons, which are the gray ones, don't have a charge. It also shows you that it's inside of a nucleus, and it shows you the electrons. Now, it doesn't show orbitals, but um, I don't see orbitals. Well, I guess it's using the where they look. Okay, I guess so. See orbitals. Can you explain more about where? Let's see where they are. Ah, very nice.
In the diagram, the orbitals are represented by the paths or loops around the nucleus where the electrons are likely to be found. These loops are not physical structures, but regions of space where electrons can move. Think of them as the paths the electrons travel on.
Can you quiz me on the atom so I can see if I remember?
I'm on it. A practice quiz.
Okay, what is the central part of an atom? Nucleus. And it's giving you just 5 questions, which is really good. Are electrons found in the nucleus of an atom? No, they're found outside, so that would have been false. But let's see, let's just get one wrong. What particle is positively charged? Let's say I say photon. It'll tell me that it's wrong. What if I say neutron? It'll tell me that it's wrong until I get it right, which is also kind of a process of elimination, but students will also remember the right or wrong answer. Does the atomic number represent number of protons? And then which part of the atom has the least mass? Now, it didn't talk about this, so I'll be guessing, right? But electrons. So I got 4 out of the 5 right. Okay. But 4 of 5 right. I don't understand the weight of the particles in an atom. Can you explain that?
In an atom, 1. Protons. Positively charged, relatively heavy. Each proton has a mass of about 1 atomic mass unit, AMU. Neutrons, neutral, about the same mass as protons, 1 AMU, adding to the atom's weight. Electrons, negatively charged, very light, almost negligible mass compared to protons and neutrons. Most of an atom's weight comes from protons and neutrons in the nucleus.
So we don't even have to worry about the weight of an electron. That's why mass is just the proton and neutron.
That's correct. Electrons are so light that their contribution to the atom's overall mass is negligible. So the atomic mass mainly comes from the protons and neutrons in the nucleus.
If the neutron number isn't on the periodic table, how do we know what it is?
To find the number of neutrons, 1. Look at the atomic mass. This is usually a decimal. Round to the nearest whole number. This gives you the mass number. Subtract the atomic number. Mass number minus atomic number equals the number of neutrons. Example, for carbon, atomic mass is about 12.5, atomic number is 6. Neutrons are 13 minus 6, which is 7.
Pretty cool. Thanks. Okay, so that is the end of that particular chat, and I just wanted to show you that it can go to different levels and explain it to you. It can explain it to your neurodivergent students a bit differently. It can give analogies. It can ask and answer why you chose a particular answer so that you can understand how it's thinking. If we go back here, I want to see, can you give me an outline of what I need to know to master calculus 1 in college? I am a chemistry major. And let's go undergrad.
When interpreting graphs of functions relevant to chemical reactions, focus on both axes. The x-axis typically represents time or concentration, while the y-axis shows reaction rate or product formation. Analyzing the slope reveals rate changes. Look for trends like linearity indicating constant rates or curves showing acceleration or deceleration, crucial for understanding reaction kinetics and mechanisms. Differential equations are essential in chemistry for modeling reaction rates. Consider a simple reaction where the rate of change in concentration of a reactant is proportional to its current concentration. This forms a first-order differential equation. D of A equals negative Ka. Solving it helps predict how concentrations evolve over time, providing insights into kinetics and equilibrium states. Today, we'll delve into integration techniques crucial for solving chemical problems. Mastering methods such as substitution, integration by parts, and partial fraction decomposition allows us to calculate areas under curves, determine volumes of irregular shapes, and analyze rate processes. These skills are essential for understanding reaction kinetics, thermodynamic properties, and diffusion rates in complex systems. Understanding limits is crucial for grasping the behavior of functions at points of interest, particularly as we approach them. In chemistry, this concept helps predict reaction rates or concentrations over time. For example, Examining the limit of a reactant concentration as time approaches infinity can indicate the reaction's completion, guiding computational models and laboratory experiments effectively.
Can you give me a basic lesson on integration? And it does not need to be related to chemistry, just math. So it can't do.
Basics of integration. Integration is a fundamental concept in calculus, often used to find areas under curves. Here's a simple overview. What is integration? Concept. Integration is the process of finding the integral of a function, which essentially sums up infinitesimally small quantities to calculate a total. Indefinite integral represents a family of functions and includes a constant of integration. C. It is the reverse process of differentiation. The integral of f of x with respect to x is f of x plus c, where
So I see that it could give
let's
conceptual
delve into
information
substitution. It's
for
used to simplify
mathematics.
integrals by
And so it'll say f of x instead of y. It'll say integral instead of integral. And you would have to know what the symbols are to be able to work through that material. I wanted to know how deep into calculus it could go, but most importantly, the fact that it could integrate subjects for me to get a better understanding as to why I am taking a particular subject as a particular major. Now, I'm pretty sure that it can relate calculus also to if you were a psychology major or if you had to take it for kinesiology. And I was just really interested to see, could it relate the concept of using calculus in chemistry, and it did a great job with that. So these are just some ways that HoloTutor can be used, and this is just the beginning interface. These sessions are actually saved on the side, so you can go back and revisit your chats. But that is what I wanted to share with you today. Um, I've used it in really interesting ways. One way that I've used it, because I have a lot of English people that are asking me how it's being used, but in order, this is a um, a grant proposal that I did, and I had it give me some insights on my writing, and so I asked it which part of my writing is strongest and where does my meaning become unclear, and it gave me that information. I asked it, how effectively am I using examples? And it gave me what strengths I had. And I asked about what specific revision would improve the impact, and it told me that. And I asked it to give me a starter paragraph based on what I wrote that would help me restate that, and it did that. I also put in an image and asked it to explain this distribution of grades that I had gotten as a data point, and how would it explain it, and it broke down that distribution of who made up the larger group of the demographics, and then I asked it to correlate the grade level of the students to their ability and aptitude, and it did that as well. But it can help you go through things. I even asked it how it felt in terms of one of my logos that I was using as part of the grant application. Did it follow certain UI principles in terms of being able to convey brand identity? And it gave me that information. And I feel like these types of information can be helpful for students if they have clear guidelines that they can also upload to get them further on how they wrote that paper, to give them context and insight on how to strengthen their papers or how to strengthen their arguments on a particular subject. But this was just another way that it could be used as well. It provides quizzes and flashcards for students. It'll create an image of something just like you saw me do before. But it goes from just general education levels, elementary, middle, high, undergrad, and graduate school levels. And I think that this platform can be very useful for all levels of education and for also prompting it to make you think a little bit more about how you're thinking and close learning gaps for students who won't ask a question in school, who won't do anything because they're too afraid of what others will say. So, if you want to reach out to me, I'm at unitethemetaverse.com. And if you want to try Holo Tutor for yourself, go to holotutor.ai. Thank you so much.